Hi everyone, for today's lesson we are going to learn about graphing circles and completing the square to find the center and radius of a circle. With our learning objectives being, I can identify the center and radius of a circle and use that information to graph a circle. So we are going to be working with the center and the radius of a circle in order for us to graph it. Then I can write an equation of a circle given the radius in either the center or a point on a circle. So we want to be able to write an equation either given the radius and either the center or given another point that is on the circle. So the standard equation or standard form of a circle with a center located at 0, 0 is the following equation: x squared plus y squared equals r squared. If our center is not at 0, 0, and it's someplace else, notice that HK has returned once again. We talked about it when we were working with vertex form. We talked about it when we were working with absolute value functions. And now, once again, HK has returned. And what you're going to find is that that is a common thing. H and K appear over and over and over again. And just like before, it represents a horizontal shift for our H value and a vertical shift with our K value. And the way that we write our equation is both are going to go inside of the parentheses. X minus H squared plus Y minus K squared is equal to R squared. So the square is on the outside. So that means that both H and K are on the inside, and the same rule is true. It is the opposite of what you see. So H and K are both going to be the opposite of what we see. So I also want you to be careful that R is the radius of the circle, not R squared. So a lot of kids will say, oh, that number 16, that means that the radius is 16. When in fact, this means our radius squared. So our radius is actually the square root. So I want you guys to be careful. So if radius squared, that means that if you take the square root, that is going to be our radius. So radius of the circle represents how wide it is from the center. So what we want to do in example number 1 is we want to graph this circle. We need to identify our radius and we need to identify our center. Now, since in this problem we have x squared plus y squared equals 9, x squared plus y squared means that our center is located at 0, 0, and I'm going to start off by plotting 0, 0. Our radius is not 9. Instead, 9 represents r squared. So if we were to take the square root of 9, that's going to equal 3. And so therefore, our radius is going to be 3. And how you come up with your points is I would recommend looking at this from a lens of north, south, east, and west. Starting at our center, I'm going to count 3 units north. 1, 2, 3. That is a point that's on my circle, and that point is located at 0, 3. Starting at my center again, I'm going to count south 3 units. 1, 2, 3. That is located at 0, negative 3. East, 1, 2, 3. That is located at 3, 0. And west, 1, 2, 3. That's located at negative 3, 0. Now we draw our circle. Don't make this look like a square. That is incorrect. We want this to look like a circle, so make sure that you are going around. It's very easy to just make this straight lines, but that is incorrect. I'll make you redo the problem. Nobody wants to do that. This is a circle. We're talking about circles. Let's go ahead and look at example number 2. In example number 2, we have 9y squared plus 9x squared equals 36. Before you are allowed to graph a circle, you need it to be in the form that you see here. Notice that there are no coefficients that are visible in front of either the parentheses or even x squared and y squared. Therefore, we have to make sure that x squared and y squared have coefficients of 1. So the first thing I'm going to do is I'm going to divide out 9 from every single term so that I can make sure that the coefficients are 1. And then I'm going to rearrange the letters so that we end up with x squared going first and then y squared, because we always put x before y alphabetical order. 36 divided by 9 is 4. My radius is going to be, my center is going to be at 0, 0 because I have an x squared and a y squared. And my radius, well, I'm going to simply take the square root of 4, and that's going to equal 2 because remember, this 4 represents r squared, not r. So you have to be really, really careful. So my radius is at 2, so I'm going to plot 0, 0, and once again I'm going to count north, south, east, and west 2 units. So counting north 2 units, 1, 2, that is located at 0, 2. South, 1, 2, that's located at 0, negative 2. East, 1, 2, that's located at 2, 0. And west, 2, 1, 2, that's at negative 2, 0. This is not a square, it is a circle, so to the very best of your ability, please go ahead and draw a circle going through all of those points. All right, these are really nice whenever the center is located at 0, 0. But what about when the center is not located at 0, 0? Remember that we are going to be working with H's and K's, and HK is going to represent the center of our circle. And HK is always the opposite of what we see inside. So I see here x plus 1 squared plus y minus 2 squared equals 16. So that means that based on the opposite of what I see, I'm going to have negative 1 and a positive 2 as my center. So I'm going to plot negative 1, positive 2. There's my center. Now, my radius is not 16. Instead, I have to take the square root of 16, and that's going to equal 4. This time around, my radius is 4. So I'm going to count up north, south, east, and west, once again, starting at my center. 1, 2, 3, 4. So this is located at negative 1, and it looks like it's at 1, 2, 3, 4, 5, 6. South, 1, 2, 3, 4. So this is located at negative 1, negative 2. East, going back to my center, 1, 2, 3, 4. This is located at 3, 2. And west, 1, 2, 3, 4. This is located at negative 5, 2. There exists a little bit of a trick, and maybe you noticed it, that all we're doing is we are either adding or subtracting 4 to the x value, or adding or subtracting 4 to the y value to get to our points going around the circle. So to the very best of your ability, go ahead and draw a circle going around the points. Circles are probably one of the hardest things to draw, so obviously that looks really ugly. Just do the very best that you can. It doesn't look like a square, and that's the most important thing. The next problem is a solo. I would like you to please complete that problem on your own. You're welcome to do it when we get back together in class, or you're welcome to do it right now and be ready to discuss. Down here we also have a pair, and in this pair it says write an equation of a circle with the center located at negative 1, negative 2, and a radius of 12. So that's going to require you to substitute these values directly into the equation and come up with your answer. So I just want you to write an equation. I think that you guys already know what that equation is going to look like since our center is located at 1, negative 2. All right, moving on. Next, we're going to be talking about a thing called points within a circle versus points outside of a circle. So if you wanted to know whether or not a certain point is located inside of a circle, what you're going to notice is that the equation is going to be x squared plus y squared is less than r squared. So it's going to be less than, which means inside, within. Outside of the circle means that we have x squared plus y squared is greater than or equal to r squared. It's outside of the circle. It's outside of r squared, bigger than. So in this problem, I recommend that you use that north, south, east, and west reference that I did in the last problems, where north is up here, south is up here, or down here, east and west, and view this like an XY coordinate plane, and that will help you as you are figuring out directions. You do not need to graph this problem, but it'll help you to identify, especially 10 miles, where 10 miles west and 24 miles south is located. It'll help you to identify whether or not they are positive or negative values. Once again, I'm going to let you guys complete that problem within your groups as a pair, or you can welcome to do it individually, but we're going to talk about that next time I see you. So what's really cool is that you can, why is this connected? Why are circles within this unit? And that's because we have these squares, the x squared and the y squared. That means that these are quadratic relations. Anytime that you have an exponent to the second power, that means that they are related to, or there is a relationship between a quadratic. And so one of the cool things about completing the square, which is what we've been talking about, is that we can use completing the square, or we can complete the square to find the center and the radius of a circle. The thing that we need to make sure that we do is we need to just be sure to group the variables together when you are completing the square. So in this problem, we have x squared plus y squared minus 10x minus 6y plus 18 equals 0. And we want to write an equation of a circle. So if you look back at our previous page and at our equation for a circle, we have x minus h squared and y minus k squared. Both of these are parentheses squared, which means before they got here, or if we were to FOIL out these two parentheses, they would both turn into perfect square trinomials. And then we don't have any additional constants. Our constant is on the other side. It's an r squared is on the other side. So what we're going to do is we're going to turn one side of the equation into two separate perfect square trinomials, and any excessive numbers are going to go on the other side. So that's exactly what we're going to do here. The first thing you want to do is group your variables together. So I'm going to bring this 18 to the other side because it doesn't make a perfect square trinomial with anything. It's not a perfect square number. So I'm bringing it to the other side, and I'm going to rearrange my terms so that I end up with x squared and minus 10x being together. Then I'm going to write plus y squared and minus 6y together, and that's going to equal negative 18. So now what I need to do is I need to complete the square with x squared minus 10x, and I need to complete the square with y squared minus 6y. Now, everything I'm about to write down, I need you guys to write down as well. When it comes to completing the square, I really need you guys to make sure that your structure is exactly the way I'm showing you, because a lot of kids get really lost in these types of problems. So what I'm about to write down, I need you guys to write down too, and follow along. If you need to rewind the video, that's perfectly fine as well. So I am going to write x squared minus 10x plus, I am going to leave a space for a new c value because this whole piece is going to turn into a perfect square trinomial, plus y squared minus 6y plus space for a new c value equals negative 18 plus, I am going to add two separate numbers on the left-hand side of the equation. So that means I need to have space for two numbers on the other side that I'm adding to 18. And what we're going to do here is we're going to complete the square twice. So I have negative 10. So remember that to find your c value, that's your b value cut in half and squared. So my b value in this case is negative 10. So that's negative 10 cut in half and squared. So that means that I have negative 5 squared, which is 25. So I'm going to add 25 on both sides of the equation. And now I need to come up with my my new c value for completing the square on the other side. So what I mean by sides is I mean working with the x's and working with the y's. So my b value is negative 6 here, and I'm going to cut it in half and square it. So that means that I have negative 3 squared, which is 9. So I'm going to add 9 to both sides. I now have a perfect square trinomial. x squared minus 10x plus 25. That's going to turn into an x minus 5 squared. Now, what I really need you guys to recognize is that there is a plus sign right here. That plus sign needs to stay in between. Plus needs to go next. Now I have myself another perfect square trinomial. Y squared minus 6y plus 9. That's a perfect square trinomial that can be broken down into y minus 3 squared equals. On the other side, I need to make sure that I combine my like terms. Negative 18 plus 25 plus 9 equals 16. There is my equation. X minus 5 squared plus y minus 3 squared equals 16. With my center being located at the opposite of what I see inside, which is 5, 3, and my radius is 4. It's the square root of 16. All right, let's do that one more time. So, looking at number 5, I'm looking and analyzing my numbers. I have x squared plus y squared minus 6x plus 8y minus 24 equals 0. 24 is not a perfect square number. It's excessive. So I'm going to bring it to the other side by adding 24 to both sides. And then I'm going to rearrange my terms so that my x's and y's are together. I have x squared minus 6x plus y squared minus 8y is equal to 24. From here, I am going to rearrange add blanks or spaces so that I can complete the square. I have x squared minus 6x plus space for a new c plus y squared minus 8y plus space for a new c equals 24 plus I need to add 2 spaces because I am adding 2 separate numbers. You might be to the point now where you can complete the square in your head. Half of negative 6 is negative 3. Negative 3 squared is 9. Half of negative 8 is negative 4. Negative 4 squared is 16. So I'm going to add 9 to both sides, and I'm going to add 16 to both sides. And now what I have here is I have 2 perfect square trinomials that I can rewrite as a parenthesis squared. So I have x minus, I'm sorry, this is a plus 8. Sorry, guys. That's a plus 8. I have an x minus 3 squared plus y plus 4 squared equals 24 plus 9 plus 16 is 49. And there's my equation. X minus 3 squared plus y plus 4 squared equals 49. My center is located at the opposite of what I see inside, and what I see on the inside is 3, negative 4. It's the opposite of what I see inside. With my radius being located at the square root, or being the square root of 49, which is 7. There's one more problem. That problem is a solo problem. Once again, I strongly recommend that you try it on your own and be ready to discuss it when we come back together in class, but you are more than welcome to wait until we get into our pairings in order for you to solve that problem. That is the end of today's lesson. If you have any questions for me, please feel free to email me. Otherwise, I hope you have a wonderful day.